Thanks both Hiba and Mahmoud for the introduction. As you said, I'm an architect. I work here at Onyx Solar, which is a company that we manufacture PV glass for building integration, okay? And yes, the main idea of this product is to help the buildings to achieve a net zero building in case it's possible. Of course, this is very complicated. Many things they still need to be done, because it's not only about local production on site, but also other type of isolation and many other measures that should be taken for this goal, okay? So, well, in my case, I'm going to focus on PV glass, which is what we manufacture, okay? And we're going to discuss the items that you can see right now in your screen, okay? So the main idea is, first we will review about PV glass itself. What is PV glass, what is composed of, the different layers of the glass, different properties, different finishes, different treatments we can offer, well, many different things we can do with the PV glass itself. Then we will move to the application of this PV glass, because, well, the main idea is it could be applied as any other constructive solution where we have conventional glass, always, of course, in the outside of the building, not in the inside. And then I will explain a little bit about the mechanical and electrical installation. And, well, finally, we will review a feasibility study we carry out in Jordan. It's only a study, it's not a real building, okay? So it's just a few slides to have an idea about this type of information. And finally, as Hiba said before, we will have some time for questions, okay? So let's start. The idea with this webinar is that once we finish the webinar, you will understand a bit more, as I said, about the PV glass, its main characteristics, the architecture of the product and its types, the mechanical and electrical installation. We will also see some constructive details. You will be able to identify the key components of the balance of system, which is the name of the electrical installation, and then to have a general idea, not a deep knowledge, but a general idea of the feasibility of a BIPV system. So let's start with the PV glass itself. So for us, it's very important that we differentiate from PV panel to PV glass. Both of them are always PV technology, photovoltaic technology, with the different generations that we have. But it's very important to clearly differentiate from PV panel to PV glass. It's very important that the PV glass, as the name itself says, it's a glass, which is a building material. It's an architectural product, okay? This leads obviously to different characteristics, such as the natural light, the different type of insulation. We can also have different type of filtering of different radiations. And also very important, the aesthetics should be aligned with the architecture, okay? Because we don't want to have a PV panel which is not architecturally interesting in a facade, for example, okay? The PV panels are very useful for other applications, but not as a architectural product, okay? So that's the first idea. It's a building material, okay? In this sense, we are not talking about a price per kilowatt, for example, or per watt, which is very typical in the photovoltaic industry. In our case, we try to move into the building material industry. So we discuss, when we talk about prices, it's about price per square meter and not price per watt, okay? Then, well, as I said before, it's a photovoltaic collector, which means that it harvests the energy generation from the sun, okay? It's going to offset the cost of other conventional building material that would be installed otherwise in the building, okay? So somehow maybe the price is going to be higher than conventional glass, but we are not going to pay the glass itself. So, well, we will make a balance on different things regarding prices, regarding the needs of the building, the needs of the client, and the approach that we are having with each different constructive solution. And then it's also very important, it's going to generate a revenue for the owner of the building, okay? Obviously, if I'm paying extra for a building material, it should give back something, and between that something, one of the different things that we can get is the revenue for the owner. Okay, so as I said, the main idea is it's a free and clean energy from the sun, which is, and it's a building material. I want to insist on that because it's a building material and not a PV panel, which is very similar in the technology, but completely different in the application. In the certificates we have, as you can see, these materials should apply and should comply with all the architectural certificates and not only with the PV certificates. So in photovoltaic technology, there are different generations. The first one was the crystalline technology, both mono and polycrystalline, okay, which is the one in the right side. Then we also have the thin film or amorphous silicon technology, okay. There are some other newer technologies, such as the organics photovoltaic, CIGS or cadmium, well, different options, which we are working on them, but only under research and development at this stage, okay. So the most extended technologies are both crystalline and amorphous silicon glasses, okay. It's a very typical question, which one is better? Which one should I pick? Well, it depends on many different things. There's not a single answer. Each of them is having different advantages and different disadvantages. So I will try to explain in the next slide, in the next slides. So as you can see here, both technologies, both glasses are always going to be composed minimum of 2 glass layers, okay? Could be 3, and we can also add the rear double glazing, triple glazing, or other things, but minimum we will have 2 glass layers. So let me start with amorphous silicon glass. As you see in the left side, we are usually going to have 3 glass layers. One is the PV glass itself, which is a float glass of 3 millimeters. And in this glass, we're going to make the deposition of the technology, of the amorphous silicon technology. So it's going to be, as I said, a float glass 3 millimeters, completely opaque. And then in order to achieve different transparency degrees, we are going to make small cuts with a laser machine. So with this, what we do is we remove the technology. We have more light coming inside of the building, but at the same time, obviously, as we remove technology, this means that we have a lower installed power per square meter, okay? The less amount of technology, obviously, the less installed power, and the more light coming inside of the building. So, as I said, this PV glass layer is always 3 millimeters, 3.2 millimeters float glass, and then we're going to add 1 or 2 glasses, depending on the application, depending on the needs of the solution, depending if it's on the size of the glass also, okay? So very commonly, it's going to be, for example, a configuration of 6 millimeters temper glass, 3 millimeters float glass with the PV layer, and then 6 millimeters float glass. So that's a very common composition, okay? We can customize many different things. Then on the right side of the slide, you can see the crystalline silicon glass, okay? Both applicable for mono and polycrystalline cells. So in this case, from top to bottom, we are going to have low iron extra clear glass, completely transparent. Then the interlayer, which is the encapsulant, okay? I will explain later on. Then we have the crystalline cells, no matter if it's mono or poly, as I said. We also offer color PV cells. Then we have another interlayer, and then we have another clear glass. So this is the most typical configuration. Could be 4 plus 4 millimeters glass, 6 plus 6, 8 plus 8. It depends, again, in the size of the glass and in the requirements of the constructive solution. Okay, so that's the main idea of the glass composition. And as you can see in the bottom side of the slide, we have many different glass treatments, many different coatings. We can use also many different interlayers. Most commonly, we're going to use PVB with thin film and EVA with crystalline because of the electrical and mechanical properties of both of them. but we can also work with centric glass or Wansiva or other type of encapsulants. Then both of them will have a junction box, which is a small piece of plastic, which is required, it's needed to harvest the energy generation, okay? So we have three different type of junction boxes, monopolar, bipolar, and the one mounted in the edge. And then in the rear side of the glass, no matter if it's thin film or crystalline, we are going to be able to have double glazing, triple glazing, filled with air, with argon. So many different configurations, many different options for customization, again, depending on the client's requirement. So talking a bit more about amorphous silicon, well, most of the things are already explained. It's 3mm float glass. We have different transparency degrees based on what I said before. With this laser, we are going to give small cuts, okay? Obviously, the more transparent, as you can see in the right side, the install power is going to be lower, in this case, 28 watt peak per square meter. And then in the case of the dark one, it's 58 watt peak per square meter. Dark glasses only make sense when we're using them in a facade, for example, as a cladding system, or maybe in a canopy or in a skylight if we combine some areas completely opaque and some areas transparent. But for example, in a curtain wall, it makes no sense because we want the light coming inside of the office space, for example, okay? It's very important. Amorphous silicon works pretty well under diffuse light conditions. This means that even if the glass is not perpendicular, the sunlight is not achieving the glass not in a perpendicular manner, it will still produce energy, okay? Of course, if it's perpendicular under perfect conditions, the performance is going to be higher, but it will still generate if it's cloudy, if it's in not the perfect orientation or not the best tilt, okay? Also very important, we're going to offer unobstructed views from the inside to the outside, okay? It's not completely clear, it's not fully transparent, but somehow it looks like a tinted glass, as you can see in the right picture. Then, amorphous silicon, we have some standard sizes, but we can also customize to a maximum of 4 by 2 meters, okay? We are offering many different colors. This color is given from the inside, not from the outside. From the outside, we will see darker. So if it's blue, it will be light blue from the inside, but dark blue from the outside, because we always have the PV layer, which is somehow making the color to be seen darker, okay? And then, well, as I explained before, here we have the 3 glass layers, the tempered glass, float glass, and then another tempered glass, okay? Again, this is customized, we can customize this. About crystalline glass, okay? We have both mono and poly, as I said before. The efficiency is going to be determined by the density of cells per square meter, okay? So obviously, the more cells per square meter, the higher install power, leading to a higher efficiency. But as you can see in the right side, the lower picture is a curtain wall. It's a medical center in Chile, in South America, where they wanted more light coming inside of the building, but they still want to produce energy. So in that case, the cells were separated. So we are having a lower install power, lower efficiency, but we are going to still produce energy and we are going to have more light coming inside of the building, okay? Obviously, the install power of crystalline cells is always higher than thin film, okay? So in terms of energy production, crystalline is always a better option than thin film. But this one is more affected by diffuse light, okay? So this one, with no direct sunlight, it will still produce, but the performance is going to be lower, okay? And compared with thin film, it's also very interesting, the options that we have with non-rectangular units. As you can see there, we have hexagonal units, triangular units, we also have circular shapes. So many different options, which with thin film are also possible, but more complicated. In this case, again, we have some standard sizes. We can also customize to a maximum of 4 by 2 meters. And as you can see in the right side, we can also offer PV cells with different colors where the efficiency is going to drop. and price is going to be higher. And then you can see also some glasses with different treatments, with acid edge, with a ceramic frit pattern in the rear side. So it's not just the PV cells and that's it. The idea is that we try to customize as much as possible to have both energy generating product, but at the same time, architectural aesthetics interesting both for the architects and for the final clients. Here we can see some advantages of using the PV glass compared with the conventional glass, okay? So the most clear and the most important one is the energy generation, which this is going to lead to more sustainable buildings because obviously we're going to have a local production of energy, which lead to a more green buildings, let's say, okay? As I said before, this is the green building, it's a concept which is far away, not only on the PV glass, but it will include many other things. So what we can offer to all those things is the energy generation, let's say. At the same time, we are offering ultraviolet and infrared filtration, which is related obviously with the acoustic and thermal isolation, okay? So both technologies are going to work different in this sense. Thin film is going to filter, we will see later on the values, but it's going to filter way more than crystalline, because in crystalline we have conventional glass, but in thin film the photovoltaic layer itself is filtering, okay? Regarding the acoustic and thermal isolation, it's not only related with the PV layer itself, but with the glass composition in general, okay? And then, well, obviously, at the same time we are generating energy, we are also reducing the emissions of CO2, okay? And a very important thing for me as an architect is that, as I said before, it's not just a glass generating energy. It's a glass which is going to offer many different properties in terms of design. We are going to have the natural light coming inside of the building, but at the same time, we have many different treatments. We can use different shapes. We can have different transparency degrees. So, of course, not everything is possible, but we try to make as many customizations as possible. Here, as I said before, we can see the properties of the PV glass compared with the conventional glass in terms of ultraviolet, infrared radiation, as well as the solar heat gain coefficient, okay? So yeah, conventional glass, well, of course, we have many different conventional glass, but a standard one is going to filter around 60% of those radiations, and the solar heat gain coefficient will depend on many different things, but it's going to be about 70 to 85%. And in our case, we're going to reduce significantly all those values, okay? So it's not only about generating energy, it's also about filtrating these type of values. So now that we know a bit more about the PV glass, how should we choose one of them? Why should I go for PV crystalline? Why should I go for PV amorphous glass? As I said before, there's not a single answer, okay? We have to consider many different questions. We have to think about many different things. Here we have some schematic questions. I'm not going to go through all of them because it's not the moment, but mainly the idea is, one thing is the power installed, the power production. Another thing is the aesthetic. What about the finance, the budget, the payback I'm looking for? So, well, it depends on many different things. The approach is going to be more related with aesthetics, maybe with budget, maybe with install power, or obviously a combination of all of them. Well, here are some examples about different approaches. So in the scenario A, we are looking for a higher install power. The picture in the left side with a very strange, yeah, that one, with a very strange rooftop. It's not done by Onyx Solar. For us, it makes no sense to have such an installation, okay? On the other hand, one of the options that we offer is one building with PV glass in the full facade, leading to a very high installed power, could be even more, but we don't need to have this weird solution in the rooftop to have energy generated glasses, okay? So that one, in this case, it's a project done in Turkey for a gas company. It's called Bursa Gas. So, well, it's enough energy compared with other strange solutions, okay? Then on the right side, we have the scenario B, where we are having a comparison, let's say, of a terrace with the walkable floor compared with a terrace with PV panels, okay? In this webinar, we do not have, I think, many real estate companies and people, well, related to that industry. We have more engineers, architects, which is obviously very close to real estate companies. But let's think in a hotel building or in an office building, which is close to the sea, and you have very nice views. So you have two options. You can have a rooftop completely covered with PV panels that you are not able to use the rooftop. So you are losing, I don't know, 1,000 square meters, 10,000 square meters of a rooftop, which can be used with a very nice bar, have a snack, have a drink, whatever it is. And on the other hand, you can offer the walkable floor, which is going to produce energy during the day. Of course, if it's full with people, it's not producing, but if it's not completely covered, some times of the day, it's going to produce energy. So, well, it's another approach, okay? How to use the roof terrace in another way, which is not only with solar panels, okay? And then in the scenario C, these high rises in Europe, in Slovakia, and they were using PV glass only in some floors, not in all the levels of the glass, because they wanted to have clear views from the inside to the outside. But in the installation levels, they don't mind about the views, so they decided to go for this type of solution. Okay, so now we're moving to different constructive solutions that we can offer, both first a mechanical approach and then the electrical approach. The main idea, as I said before, is we can include PV glass in any constructive solution where we are using conventional glass. Of course, not inside of the buildings, but any solution in the envelope of the building where we're using conventional glass, we can also install PV glass. So let's see some different applications through real projects and with some details of those projects. Okay, so first, rain screen cladding or ventilated facade, however you want to call it. Okay, so this is our headquarters in Spain. It was an existing building where we have decided to cover with like a double skin this type of cladding system. Okay, in this case we are using amorphous silicon glass combining both dark and 20% transparency degree, because there were some areas with windows and some areas with spandrel concrete. So there's no need of having transparency degree over the concrete. Okay, so well, as you can see, the configuration of this glass on the right side, and we are using in this case monopolar junction box, which is two boxes. Each one is going to have the positive and the other one the negative pole to connect each glass with the next glass. Here we can see this was the white building was the existing glass. The existing building, I'm sorry. So, well, as you can see, the installation is very easy to be done. So from 1 to 5, first we are going to install the brackets. Then on the second picture, you can see the vertical structural system that we're using, aluminum profiles in this case. Then we're going to fix the cable trays to the wall because the wires will run through those trays in this case. In this building, we are also installing. We also install the the isolation material, in this case, rock wool. And then we install the glass itself with a clamping system, which is very easy to install, okay? Now we have another application, which is a curtain wall system. This is a store in Miami, in United States. It's for Balenciaga. In this case, this curtain wall was composed of crystalline PV cells, okay? Usually for this type of stores, they choose the other aesthetic, but in this case, the designers wanted to go for this type of aesthetic. As you can see on the right side, we have a glass which is 6+6 millimeters. Then we have the spacer filled with argon, and then we have the rear glass, in this case, composed again of 6+6 millimeters, okay? This glass is including what we call a lateral junction box or edge-mounted junction box, which means that we are seeing absolutely nothing of the wiring system. So we are going to see absolutely no wires. Of course, this lateral edge, this edge-mounted junction box will need to be incorporated in the aluminum framing, but this is very easy. Any conventional framing that we are using with conventional glass, we can also use with the PV glass. The only thing we have to study where are we going to install the junction boxes and where are we going to run the wires. In this case, the install power per square meter was 107 watt per square meter. Here we see some other details of this same installation and different and some other installations that we can use with our PV glass. Okay, and in the picture number 4, you can see the lateral junction boxes. This is a picture in our factory before making the shipment to the site. Okay, this is another curtain wall system, in this case with thin film, 10% transparency degree, 40 watt per square meter. Again, it's a double glazing solution. In this case, the second layer is composed only with one glass of 6 millimeter. And well, we're having here the same type of junction box as before. Again, another curtain wall system with thin film again, 20%. This one is seen from the inside. This project is located in Canada. And again, here, if you look for it, you don't see the wires, you don't see the junction boxes. In some cases, we can see them. For example, let me go back. In this project, from the outside, we do not see the junction boxes, but from the inside, we see them, okay? Why? Well, this is architect's decision together with the client and with the engineers, okay? So from our side, we don't mind if you want to see them, you want not to see them, it's not in our hands, okay? So this one, as I said, they are seen from the inside. And in this case, we see absolutely no wires. Everything is hidden inside the structural system, the aluminum framing, okay? So this one, as I said, it's 20% light transmittance, leading to 34 watt peak per square meter. Well, we move now to a skylight application. This project is located in New Jersey. It's for Bell Works. This one is somehow for us is very representative because Bell Works company was supposed to be the pioneers in solar cells. So that company was supposed to manufacture the first solar cell ever, okay? So now, I think it was 1 or 2 years ago, I'm not sure, we installed the skylight of this building, which is the headquarters of Bell Works in New Jersey. It's a bit more than, it's around 6,000 square meters. And well, it's very representative in this case. So the skylight solution is very similar to the curtain wall. Indeed, is almost the same, but horizontal instead of being vertical, okay? So the idea again is the framing system is going to be the same. The aluminium profile is going to be the same. So everything is the same, let's say. And in this case, we have a bipolar junction box with two wires, the positive and the negative wire. In this case, usually for a skylight, they prefer to use double glazing, but in this case, they wanted to go for single glazing. This is a customized solution because as it was an existing building, the retrofitting, they wanted to keep the same framing, and they just remove the existing glass and they install our PV glass, okay? In this case, in this picture, it's very complicated to see the junction box, but if we move closer to the glasses, we really see the junction box. So in this case, it's seen, but the decision was not to have it completely hidden, because as we have a very big height in this courtyard, to be honest, I've never been there because this was managed from our office in New York. But if you walk inside this building, there's a big space from the skylight to the floor level. So it's far away and we don't really see the wires. We will see them very small, okay? So, well, this is another solution that we can use, okay? Another application, again, is another skylight, in this case with crystalline. Usually crystalline technology works better with in a skylight solutions because we are going to give shadow to the inside of the building, and we are also having a higher install power, okay? Again, in the previous one, we are also filtering ultraviolet and infrared radiation. We are also reducing the sun coming inside of the building, but in a more homogeneous way than this one, which is, we will have hard shadow and light coming also inside of the building, okay? Well, here you also see the details of the aluminum framing system. And well, in this case, we have 129 baht per square meter in this monocrystalline solution. Another option is a canopy. In this case, again, we have amorphous silicon 20% transparency degree. This is a private residence in California. And in this case, the junction boxes are monopolar, and if you look for them, you will see them because they are just aligned with the beams, okay? Beams. So you see them, but you have to look for them, let's say. Well, here is the detail of the same junction box, as I said before. And here you can see pretty well in the left side, each glass is going to be connected with the next glass in a positive, negative male-female click system, so very easy to be installed, no complications in that sense. Well, here we have other canopy applications. This one in the left side is Mohammed VI University in Morocco, in Marrakesh, and the other pictures are for Miami Heat Stadium in United States. And as you can see there, as I said before, we also have circular shaped glasses, which are functional. Another option, another application for the PV glass is vertical or horizontal fins, okay? In this case, it's thin film technology, again, 20% transparency degree, and they are placed in vertical, in perpendicular to the facade itself, okay? We have here the details of this solution, but again, as I've been saying for the last 30 minutes, the idea is that we can use the same aluminum framing, the same solution that we can use with the conventional glass. We can also use it as a walkable floor. As I said before, this picture compared with the PV panels. So in this case, it's a private residence in Manhattan with an anti-slip finish, obviously, because elsewhere we will not be able to use it, to install it, okay? And in the right side, you can see some color glasses. The right picture and the left picture, they are exactly the same area, the same terrace, but as I explained before, the color from the inside, from under the glass in this case, it's seen more clear than from the face which is facing the sun. Okay, so in the left side would you see the colors, but black colors, dark colors, and in the right side they are lighter colors. Again, in this case, the walkable floor is going to be installed as any other walkable floor, technical floor, okay? This is one of our top projects in terms of the company, the final client, and the architect firm. Well, you will recognize the magazine itself. It's an Apple store, obviously in San Francisco. And in this case, they are using the walkable floor. It's a customized solution. Crystalline silicon, a walkable floor, we have a standard size of 750 by 750 millimeters, but we can also customize. And this one was designed by Norman Foster Architects. Well, before I move to the feasibility study, which is going to be the last part of the presentation, just a quick note about the electrical installation. I'm not an engineer, I'm not an expert on this part. I have the general knowledge. And the main idea is that we need to study, we need to think, we need to consider what type of junction boxes are we going to use, what type of wirings and how are we going to connect them, and what is the general strategy that we're having for the electrical installation, okay? So one thing is the mechanical part, which is pretty easy. Another thing is the electrical installation, which is the same concept as conventional PV panel, but obviously we need to know what are we going to do with the wires. Do we want them seen? Do we want them not seen? So we need to have this whole idea in our mind, okay? And then based on that, we will answer many different questions, as you can see in the left side, to focus on what is the best solution. And as a general idea of the electrical installation, we have different type of options: off-grid, grid-tied, hybrid. This depends first on the regulation of each country and then on the needs of each project, okay? If we have a hospital in Africa where the connection is shut down every 3 hours, maybe we want local production with batteries to storage, so it will produce. We will use the production from the batteries when we don't have the grid working. Okay. Well, as I said, it depends on many different things. Okay, so we have different approaches in that sense. Okay, it's important to know also that the electrical installation, we have the direct current area and the alternate current. Okay, we will have the inverters. This is mandatory. Each inverter is going to allocate different number of units, different number of strings, each string having different number of units. And this is going to be determined by the electrical engineers that will make the design, the electrical design, depending on the glass itself, depending on the building. The main idea is that we need to connect glasses with exactly the same outputs and the same electrical properties. Okay, so it's not possible to connect crystalline together with thin film, but if we want to combine both of them in a project, we will have different inverters. It's not possible to connect the same type of glass installed in a skylight and in the same building, in the same location, installed in a facade, because the production of the skylight is going to be different than the production in the facade, which means that we are going to have different outputs and we are going to have different values, and the lower performance will affect the higher performance. So that's the main idea of the electrical installation. And then all the components of these electrical installations are called the balance of system, the BOS. And here you can see all those components, okay? Very typical questions, the battery. This is not mandatory. This is going to make the full system more expensive. So our recommendation is not to use it unless there's any reason which makes it mandatory. Well, just a quick note here about the LEED certification. Well, most of you should be, I guess, aware about this certification. We are not a LEED consultant. Again, we're a manufacturer of PV glass, so we do not know absolutely all the details, but somehow our glasses, depending on the technology, on the location, on the type of building, on the type of application, depending on many things, we will have different LEED credits. Okay, so just to let you know, this is just a quick note. Well, this is just a general idea about Onyx Solar, which is our company. We have the headquarters in Spain. We have offices in Madrid, in New York, and Shanghai. We can produce more than 200,000 square meters per year. We've done lots of projects all around the world. We have lots of awards. And the most important thing here for me is that we try to innovate again. We have a research and development team which is working hand by hand with universities, with European commissions, and we try to innovate, and all those research and development projects, we try to incorporate them in our commercial products. Okay, and then with this I'm finishing because I want to not to exceed the 45 minutes I was supposed to talk, so we have some time for questions. We prepare feasibility studies for every single project, but in many occasions people reaches us and they tell me, okay, what I'm going to be able to get. So I don't know all the details of the project. We don't know what are you going to do exactly. We don't know if you want a curtain wall, a skylight, a canopy. So we have prepared what we call preliminary feasibility studies, which, as I said, they are not real cases. They are just simulations, okay? And in those preliminary studies, feasibility studies, what we do is we combine first, we consider both amorphous silicon and crystalline silicon. So both technologies are included. Then the second point, as you can see there, we are considering many different applications, okay? So a double skin, a curtain wall, canopy, a skylight, so many different applications, okay? And then to those applications and to those technologies, so we consider both technologies for each of the integrations, okay? And then another thing we do is, which is the third point, as you can see there, we consider, for example, if we have a skylight, okay? It's completely horizontal. In the case of the skylight, there's no orientation because if it's completely horizontal, the orientation is not going to affect the production. But on the other hand, if we have a facade, for example, we are going to offer the data for south orientation, and then we are going to indicate there the energy losses and per the different orientation as an approximate value. Okay, so for example, we have a facade facing south, you will have these numbers. But if the same facade is facing west, east, or north, you are going to have a loss of approximately 22%, 22, or 59%, okay? So what we have with this approach is that combining the two technologies, the 8 different integration and the 4 different orientations of each solution, we are going to have lots of different numbers, lots of different data for a generic building. And then we can move to make the study of your specific project. I'm bringing here just an example of a PV canopy, okay? In this case, is in Jordan. So it's a PV canopy. And as you can see here, what we have is first, in the first column, we have, well, the characteristics of the installation. We have the environmental benefits composed of the electricity generated, the CO2 avoided, emissions avoided, and some other values that we want to translate, let's say, from energy to something easier to understand, which is the light points that we can fit, okay? And then we have the economic benefits, okay? Different values of the economic benefits. So that's the first column. The second column is the amorphous silicon glass, and the third one, the crystalline silicon, with the results of both options, okay? And then on the right side, as I said before, we explain what we have considered. In this case, the tilt is 0%, the orientation, well, south, but it's not affecting. And then, well, this is a canopy, so there's no energy losses as the canopy is considered horizontal, but if it's with another tilt, it will have some losses, okay? All this data is calculated as indicated under the table for a period of 35 years, which is the lifespan of our products, okay? So again, this is an approximation, some values for a canopy in Jordan, okay? So that's all from my side. I hope you enjoyed the presentation. I hope you learn a little bit more about the PV glass and the different applications and some mechanical and electrical ideas. And well, I hope you enjoy it. So Hiba, I think now it's your turn to discuss about the questions.
Yeah, thank you so much, Diego, for the valuable information. We're ready now for questions. We have two hands now from Tesla Energy.
Hello.
Can you type? Yes.
My question is, how do you compare this PV glass solution you have with the Tesla glass roof, and what's the efficiency of yours, and how do you compare it as well to Hanergy Alta Devices SIGS glass that they use for BIB installations?
Mm-hmm. Okay, well, thanks for your question. To be honest, I don't know all the details of Tesla and Hanergy. Okay, that's first. As far as I know, Tesla is offering these tiles, the PV tiles. Okay, so somehow they are just focused on one solution, which is the PV tiles. Okay, and the product they offer, again, I'm not an expert on that. I don't know all the details. Okay, so I might be wrong, but the product they offer is focused only on this rooftop solution, and it comes prepared to be installed as a tile. Okay, in our case, we have lots of different solutions. The application is different because usually it's compared more not with a tile, but with a conventional glass, meaning that we're using the aluminum framing, the clamping system, the spider system. So the fixation system is going to be different, okay? And then the technology, well, we offer different technologies. I think Tesla is working also, correct me if I'm wrong, with crystalline technology. So in that sense, we have one technology which is the same and the other technology which is different, okay? You were also asking about Hanergy. I know Hanergy, from Hanergy I know even less than from Tesla, but as far as I know, Hanergy is coming from the conventional PV panels industry, and they are using, my feeling is that they are using only a glass which is 2.5 or 3 millimeters plus 2.5 or 3 millimeters, okay? So this product, if it's the one I have in mind, again, I'm not an expert on Hanergy. So this product is offering, it's not a PV panel because usually a PV panel is composed of one glass and then a plastic material, whatever it's the name, okay? Glass Tedlar usually. In our case, it's always glass, and Hanergy is offering something in between because it's only offering 3 and 3 millimeters glass. They are trying to use it as a BIPV solution, but as far as I know, they do not comply with all the architectural standards, okay? So in our case, we have some glasses that they are not complying with all the architectural standards, and our glass has a thicker configuration than Hanergy. So I guess Hanergy, or this configuration, I'm not talking about Hanergy itself, but this configuration is not offering all the architectural standards. Okay, so maybe it's better for other applications. I'm not saying we are better than Tesla or than Hanergy. I'm saying it's different. Okay, so maybe Hanergy, this 3+3 or 2.2+2.2 is for other applications. But for example, I'm pretty sure that in your office you will not want to install this 2.25 plus 2.5 millimeters as the curtain wall, because it's going to be broken and it's not safety glass. Okay, again, maybe I'm assuming things which are not real because I'm not an expert on those products. Okay.
Sounds great. Majd, also, we have a question from Majd.
I want to thank you. Thank you so much. So thank you for the insightful presentation today. But I have a question. Now, for me, I'm a student of architecture, so I don't have a lot of technical knowledge.
Mm-hmm.
But I find myself interested in sustainable technologies and all of that. So my question mainly is about efficiency. Now, in the slides that you presented, you showed about like only 18 or 17% of efficiency of PV glass. Like the input transferred into energy is, I think, it's relatively low. So aren't there like any better alternatives for the future, or at least like aspirations for future development in that field to increase efficiency?
Well, as I said before, we manufacture PV glass. We do not manufacture the PV cells. Okay, so we are using the same PV cells as they are going to be used in conventional PV panels. Okay, so somehow the efficiency of our modules, because we are talking there the efficiency of our modules, not the efficiency of the PV cell itself, okay, it's going to be determined by the PV cells manufacturers, okay? So right now we are about 4.26, 4.3, 4 point something watt per cell, okay? In some cases we are coming up to 5 or 5 something watt per cell. So, well, as you know, the PV cell industry has been increasing the efficiency for a while, and somehow, as I said, we are not into the manufacturing of the PV cell itself. So from our side, directly, we are not going to increase this efficiency because it's not in our hands. We are not into that, okay? But I'm pretty sure, well, from time to time, there's a new company saying that the efficiency is going up, 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 which for sure it will happen. I don't know when, and I don't know how.
Okay, so in case of this low efficiency, how can we consider this PV glass sustainable when efficiency, I think, is like, could be a milestone for sustainability?
So what's the question? How we consider it sustainable?
Yeah, it's just like a general question.
Well, I don't know exactly what you mean with how can we consider it sustainable, but obviously any product, not just a PV glass, but a PV panel or any other local product which is going to produce energy locally, which is going to reduce the consumption of other type of energy, fuel energy or other type of sources. We're going to reduce the CO2 emissions. So there are many different things, not only in our PV glass, but in general, in any building material or any energy solution, let's say, which is generating energy locally, somehow it's into the sustainability industry, right?
Mm-hmm. Thank you.
Sure.
Any more questions from anyone? Yeah, we're almost reaching the end of the seminar time. Again, thank you so much, Diego.
Sure.
Yeah, that's really valuable information and knowledge. Again, it contributes towards the energy efficiency, and we all agree it's not the only element we can provide in green buildings. However, we're open up for new technologies more and more.
Yes, Eva. So. Yes, in this event, in this joint event that we have between the two committees of Jordan Engineering Associations, the Energy and the Green Building. It was our pleasure that we introduce you as a professional in this domain, this technology of integrating the PV photovoltaic glass for buildings. Now to Jordan markets through you as a professional in this domain. In terms of feasibility study that Mr. Diego shared with us, suppose I want to have an example, which is the housing bank nearby in Shmisal. If we do that feasibility study, just to imagine how much energy we can save and revenue out of using this kind of technology rather than the technology that has been used. So I will leave this to you, and we will have a lot of activities in this regard, highlighting the latest technology and for the energy and integrated with the green energy as well. Thank you, Diego, for this contribution. That will be highly of great value for all of us in Jordan. Now, I'd like to thank the colleagues that joined this event from different countries than Jordan. Thank you for all attending this valuable session.
Great, thank you so much. Thank you, everyone.
Thank you. It was my pleasure
Okay,
to
have
be
a
here
great
with
day
you.
and stay safe.
Thank you. Bye-bye.
Bye.